Let's start with what concavity actually means before we test for it. A graph is concave up when its slope is increasing, so the curve bends upward like a cup. A graph is concave down when its slope is decreasing, so the curve bends downward like a frown. The sign of the second derivative tells us which one we're looking at. Positive means concave up, negative means concave down. Now let's apply this with the second derivative test on a real function. Our function is x to the fourth minus 4x cubed plus 2. First we take the derivative, 4x cubed minus 12x squared. Taking the derivative again gives the second derivative, 12x squared minus 24x. We factor and set it equal to 0 to find where concavity might change, 12x times x minus 2. That gives us the critical zeros of the second derivative, x equals 0 and x equals 2. We test a value in each interval to see whether the second derivative is positive or negative. Where the second derivative is positive, the graph is concave up, before 0 and after 2. Where it's negative, between 0 and 2, the graph is concave down. Here's the graph of our function so we can see it happening visually. Green for concave up, red for concave down, matching exactly what our sign chart predicted. Next, let's find a point of inflection, where concavity actually changes. Our function is x to the 2/3 times x minus 5. Solving the second derivative equal to 0. And checking where it's undefined. We find a candidate at x equals -1. The graph changes from concave down to concave up exactly at that point, confirming it's a true inflection point. Remember, a 0 of the second derivative is only an inflection point if the sign actually changes on either side. Finally, let's connect concavity to tangent line approximations, using 3x squared plus 2. Since the second derivative is always 6, which is positive, this graph is always concave up. We draw the tangent line at x equals 1. Because the graph curves away above the tangent line. When we use the tangent to estimate a nearby value, like at 1.1, the tangent line sits below the actual curve. This means our approximation is always an underestimate whenever the graph is concave up. Let's recap everything we just covered. The second derivative test tells us concavity. Where its sign changes, we get an inflection point. And concavity tells us whether a tangent line approximation over or underestimates the true function.